Good morning or good afternoon, everybody. I have a bell ringer for you guys to look at, so please pause the video and have students work through the bell ringer here, and we'll come back with an answer. Okay, so I gave this equation to you guys on the last class period, and remember the new piece here was n. If we didn't have the n here, then it would just be like a simple compound or a simple exponential growth equation, right? So that n is the new piece to the equation. So P is your principal, so we're starting with $12,000. 1 plus my rate, which is 5.3, so we got to do 0.053 over n says compounded quarterly. So quarterly, there's 4 quarters in a year. It's down here and up here, and we're compounding for 5 years. So generally where people run into problems here is plugging this stuff into their calculator. This is probably the best one to get rid of first if you have one of the calculators that doesn't do exponents very well. And then from there, you can just type it as you see it. So 12,000, parentheses, 1 plus 0.053 divided by 4 to the 20th power. And you can see we get a dollar amount of $15,613.98. Since this is a dollar amount, you want to round to the cents, the second place there. That'd be 0.98. And then here we have an inequality where we're using exponents to solve this. So remember, we want to get the bases to be the same on these. And we can't make that a bigger one, we can make this one a smaller one, because we want to get a base of 5. So I'm going to leave the 5 on the left. I have 2x minus 7 as an exponent. Less than. So what is 125 as a base of 5? That's 5 to the third power. Once we get those set up, we can get rid of those bases. We have 2x minus 7. Oops. We have 2x minus 7 is less than 3, and we can just solve that like a general inequality. So I have 2x is less than 10. Divide both sides by 2. And we have x is less than 5. And you can plug that in. Remember, if you wanted to check, you would plug in like 4.99 if I wanted to check to see if that worked, because x has to be less than 5. Okay? So before we get started on the lesson, I want you guys to help each other with any questions you might have on the homework. Odds are somebody worked through some questions that other people had problems with, so take the next 5 to 10 minutes to compare answers and work through questions that people may have. So this is not a free-for-all where if you didn't get it done, you're just copying homework down. This is if you have questions, then it's time to answer questions. So pause the video for a little bit and then come back to the lesson. All right, so we're working with logarithms today. Okay, so this is 6-4 logarithms and logarithmic functions. So starting out here, I don't think logarithms are too bad. Today is just kind of rearranging, and then we're going to be working on what really does a logarithm give me, and we're going to be graphing logarithmic functions. Okay, so looking at properties, I guess this would be a how you rearrange a logarithm. Normally have a base to some exponent, and when that evaluates, it gets some number, right? So if we said 2 to the third, hey, that's going to be an 8. That's what you guys are used to seeing. Now logarithms kind of switch things around. Logarithms are going to tell me what exponent is going to give me the number I'm looking for. So if I use this example here, I would have logarithm with a base of 2, right, because that's my base. I've used that word before. The base is now down here. Logarithm with a base of 2, 8 inside that logarithm. So this is asking me, if I have a base of 2 and a number that's 8, well, what's the exponent that gets me a 2 to an 8? That's going to be a 3. So you can see logarithms are essentially a way to get exponents from numbers. And today the ones that we're going to be working with are going to be fairly simple like this, but we're going to be working with rewriting them. So this is my base of an exponential. This is my base of a logarithm. That should be a pretty straightforward switch. And then remember that the exponent for whatever base you have, the logarithm is always going to be set equal to that. All right. So one way that you can remember this is the check mark method. So I check from the base to the other side. So this is base to the power. So I check from base to power. All right. And then similarly, if you have something that's an exponential, you can tell what's going to be inside the logarithm. So base to number. Okay, check base to x, b to x. That's going to be inside of a log if I'm switching from one to the other. Some people might also call this the dab, where you dab and your elbow kind of makes that check mark there if you want to. But there's a few things we also have to remember in order for logarithms to work. So let me get rid of this stuff, get it out of the way. So in order for logarithms to work, the base has to be greater than 0. We can't have a log base b, and you don't want to have 0 to some power because it's always 0 anyways. And the number inside of the logarithm has to be greater than 0. Because remember, this is like trying to figure out a base to what a base turned into this number. You can't turn a regular number into 0 by using some exponent. So we can't have zeros inside of an exponent or inside of a logarithm, and we can't have negatives. Okay, because you're never going to have an exponent that turns a number into a negative. I know sometimes we've tried to do that, but that doesn't work that way. Okay, so you can see here everything that's kind of connected. The base is here. This is logarithms on the left here. Base is here, base is here. Logarithm is equal to an exponent of the base. Okay, so let's try one of them. So I kind of did this already. Do you remember? It was just on the last slide. So rewrite this in exponential form. We are starting with a log. We want to rewrite this to exponential. So we are going to use the check mark. Check from the base to the other side. Okay, so this is my base. So it's going to be 2 to the third is equal to 8. And when you write that out, it should make sense. You should know that 2 to the third is equal to 8. So I, again, check mark from the base. I go past the equal sign to the other side. So I call that check mark method. Okay, there's check mark methods in other contexts in math as well. Now let's give these a try here. Same kind of idea. So in your notes, you want to have a few examples. So write down at least the next 2 examples, and we're going to see if they make sense when we use our check mark method and write them out. Okay, so I have log base 4 of 1 equals 0. So that's how we read that. Log base 4 of 1 equals 0. So I check mark 4 to the 0. 4 to the 0 power equals 1. Does that make sense? Yes. Okay, anything to the 0 power equals 1. So that works. Next one. If we do 12 to the first power equals 12. Does that make sense? Yes. Okay, so hopefully you're seeing that these aren't too bad, just rewriting them. Now when we get to fractional bases like this one, it takes a little bit more mental work, but it's still not bad. Okay, so if we do 1/4 to the negative 1 equals 4. Does that make sense? Well, we got to remember what a negative exponent does to our fraction. So a negative exponent is going to flip that fraction, which will turn it into 4 over 1, which works. Okay, so now here, some people have calculators that they can use this, or that they can do this calculation in, but you want to be able to do this without a calculator, because that's kind of important for when we take our next quiz or test. You're going to have to do this stuff without a calculator. Okay, so we don't know what this stuff evaluates to. Okay, remember how logarithms work. 4 to what power gets me 64? That's how you evaluate the logarithm. Now I'm going to show you a method to kind of visualize it. I don't know what this evaluates to, so I'm going to set it equal to x. Okay, I'm going to figure it out. So then I'm going to do a check mark. Boom, boom. So that sets up like this. 4 to the x equals 64. And now you can say, well, what power of x is going to get me 64? Or you can do it like we did the last lesson. Okay, we get the same base. 4 to the x equals 4 to the third. you get rid of your 4's, x equals 3. So this logarithm evaluates to a 3. Okay, and again, 4 to what power gets me 64. That's how we evaluate logarithms. All right. Now this one's a little bit different because we have a decimal thrown at you. All right, so let's maybe do this one like we did the last one. So we set it equal to x, 5 to the x equals 0.2. Now you might still be kind of curious of what I'm supposed to do here. Well, I'm going to take that 0.2 and I'm going to change that into a fraction. It might be easier to see if we have it as a fraction. So that's 2/10, right? That's the way you read that decimal, 2/10. So I can reduce that to 1/5. And now hopefully you can see what the x should be, or what this logarithm is going to evaluate to. Okay, what exponent will get me 1/5? That's going to be a -1. So x equals -1. Okay, so I want you guys to try these next two here. So if you wanted to, the sub can pause the video, or someone can pause the video and you can try them and then resume. I'm going to keep going here. Okay, so 1/5 to the x equals 125. So again, this one might be a little bit more difficult because you have a fraction and a whole number. So what base are you going to use for these? Well, I kind of see 5s in these, so probably a 5. And this is going to be 5 to the -1, right? Because that's how we rewrite 1/5. And this is going to be 5 to the 3rd over here. So you can kind of get rid of our bases. We have -x equals 3, so x equals -3. And then over here, this one's a little bit easier. 36 to the x equals 6. Now this one you might be kind of second guessing, well, how am I going to get from a 36 to a 6? Well, you can know that that's a square root, but then you have to remember what the exponent is for a square root. If you don't remember that, then do it like we did our last lesson. So 6 squared is the same thing as 36, and we have that x up there. And this is 6 to the 1st over here. Get rid of the bases. We have 2x equals 1. Divide the 2, x equals 1/2. So remember, a square root is a 1/2 exponent. So this part gets into actually using the buttons on your calculator. It's just as straightforward as pressing log and then 8. Some people's calculators, it's along the left-hand side. Some people might be up in the upper left-hand corner. But generally, if you press the log button, it might open up a parenthesis like that, and then you just enter the number in there. So if I enter log of 8 in there, I get a 0.903 ... Okay? And these are actually called common logs, so they're base 10. So if you see a logarithm without a base, then that's going to be assuming that it's a base 10. It's a common log. Okay? And you can check this to see if to see how the calculator gets it by doing just what we did in the last slide there. So watch this. If we do 10 to the x equals 8, so then it's like what power of 10 is going to get us to 8? So if you do 10 to the 0.903 power, you're going to get really close to 8. Okay? So 10 to the 0.903 power gets me to about 7.998. So really you need to use the entire decimal and you're going to get exactly 8 if you do 10 to that power. So it's kind of cool. Common logs are base 10, and then down here we have what's called a natural log, so that's ln. Why they do ln, I don't know, probably something to do with Greek or Latin roots, but you're going to see me write it like this, just so the L doesn't look like an N. But you do exactly the same thing. So if you do natural log of 0.3, you're going to get a -1.2-ish. And there's a bunch of other decimals that go along with that. But natural log is what's called base E. This is Euler's number, and we'll be working through that in the next couple of lessons. Okay, so just using logs and natural logs in your calculator. This is the big one, but actually this one is used quite a bit for exponential growth and decay. But this one is used more for solving equations and such. Okay, so now we're going to work the other direction. We're going to change from exponentials to logarithmic form. All right, and we're just going to work through a couple of these, and then you'll have a chance for a break, and then we'll work on graphing some of these. Okay. So if you remember previously, I talked about the check mark method on the logarithm. It works the same here. Okay, so we check from there to there, but we're switching these into logarithms. Okay, so remember, this is the base, and this is the number that's inside the logarithm. They're connected. So I do log base 9 of 5 equals x. The exponent is always on the right-hand side of the log. It's always away from the log. Okay, so my base of 9, my number inside the log is 5, and my exponent is x. Okay, let's look at this one. So same thing, we go check mark, boom, boom. Log base 5 of x equals -2. Okay, now since we're just starting off with logarithms, these ones we don't really need to evaluate these. We're just switching from exponentials to logs. Okay, so it's more important just to know how to go from one to the other. Okay, down here, same kind of deal. This one is just a little bit more specific. E and 5 minus y, this entire group goes inside the logarithm. Okay, so log base e of 5 minus y, so you want to write that in parentheses so you know the whole thing is inside the logarithm, equals x. Okay, and then we can be a little nicer and fix this. What does log base e turn into? That's that natural log thing that I just talked about on the last slide. So natural log of 5 minus y is equal to x. And that's how we rewrite this one to a logarithm. Okay, this one's going to be log base 81 of 9 equals 1/2. And you could actually check this one if you wanted to, just by looking at this one. Does it make sense? Does 81 to the 1/2 equal 9? Yeah, that's how that one works out. Okay, so take a quick break. You can stand up, you can stretch out, you can walk around the room, take about 1.5 to 2 minutes, and then we're going to resume the lesson. So please pause the video, give the students a quick break, and then get back to it. All right, so we need to look at graphing logarithms next. Okay, so these are the parent functions of logarithms. I mentioned these the other day in our lesson because remember, if we're graphing one function, then generally at this point in time we're going to graph the inverse. So logarithms are the inverses of exponentials. Okay, so we want to graph those if we had inverses. So they're going to look like this, where you have log base b of x, and notice that the domain and range from previous graphs are switched. So this one is going to go down forever, and it's going to kind of creep up forever. So the range for logarithmic graphs is going to be all real numbers, and the domain of logarithmic graphs depend on the asymptote. So it's always going to be x is greater than some asymptote that we have. Oops, curly brackets. Okay, it's never going to touch that. It's just going to get infinitely close. Okay, so in this case, just our base log x equation, our asymptote is 0, so x has got to be greater than 0. All right, so let's check one of these out. So when we graph these, we kind of want to do it like our square root equations, where you have to be kind of tactical about what you plug into the x value. Okay, there's a couple different ways you can do these, but since we're in the square root set of mind here, we can kind of do it that way. So we're going to make an XY chart, and it might be kind of difficult at this point in time, but let's try it. We need to figure out numbers that work nice in here in this logarithm. Okay, so let's just think about here how they work. So log base 3 of x, let's say, remember, 3 to some power equals that number. So 3 to some power is going to be x. So really, we want to plug in some power of the base here. So you want to use the power of that base in your XY chart. Okay, so let's start off with the simplest. Let's start off with a 3. All right, if we do log base 3 of 3, that's going to be a 1, right? So if we plug a 3 in there, we're going to get a 1. Well, what's the next power up? Log base 3 of 9, that's going to be a 2. Okay, so 9 is my x, and I get a 2 back out. The next power, log base 3 of 27, we get a 3 out. But 27 is going to be pretty beefy to graph, so let's see if we can think about going the other way. What's another power of 3? This one might be kind of difficult to see. If I do log base 3 of 1, 3 to what power gets me a 1? That's a 0. Okay, so 1 was the x value I plugged in. I got a 0 back out. Now let's kind of keep going that way. So what's if I think about my powers being over here? I got 1, 2, 3, 0. Now I'm working the other direction. So log base 3 of what is going to be 1/3 is a -1. Okay, so I have 1/3 is a -1, and then you can see 1/9 is a -2. That's our XY chart. You can see that the x and y values are inverted from previous graphs. Okay, so we're going to go ahead and graph these. Now 1/9 is kind of ugly to graph, so we're just going to kind of eyeball it. 1/3 we can kind of move out a little bit. Okay, so 1/3, -1, 1, 0, 3, 1, and 9, 2. So there is our graph. I want to continue on. Oops, I don't want to pass that. And it goes down. So this is never going to pass 0. It's just kind of hard to graph on the tablet. So if we want domain and range, remember we said range is all real numbers because they're switched around. We can plug whatever we want into the y value, or this is going to go down forever and up forever. The domain, x is greater than 0. It's not going to cross 0, even though I kind of did there. So we know that our asymptote here is going to be 0 just because there is nothing inside with the x. Okay, when we look at the general form here, you're going to look for anything inside with the x, and that's going to tell you where your asymptote is. When we're looking at general form here, just like any general form before, you have A, which tells you dilation or reflection, H is going to tell you shift left or right, and K is going to tell you shift up or down. This right here is the important piece to note, because this is going to tell you where the asymptote is. Okay, this will be x equals something for the asymptote. And you're always going to think opposite, like your vertex form stuff. Okay, if this is x minus 2, your asymptote's at x equals 2. On exponential equations, this was where the asymptote was before, but now since it's inverses, we're switched. This is where the asymptote is going to be. Okay, so if you want to write this stuff down, you can. I would definitely write this general form down and note that the h is going to tell me where the asymptote is before we graph. So we have 1/3 times log base 6 of x minus 1. Okay, so we want this x to be powers of 6. All right, as you saw that I had before. Hopefully you can kind of make an easy prediction. What's the first one going to be? Log base 6 of something equals a -2. Well, what's 6 to the -2 power? Okay, 6 to the -2 power is 136. So hopefully you can see your first number is 136, and then we're kind of going from there. Got 1, 6, and then we want a 1. And then a 6 and a 36. Now I don't expect you to graph that. It's getting kind of out there. But I do expect you to graph at least these 4. Okay? And now these are not going to give me my -2 to +2 here because we have more stuff going on. We have this going on and we have this going on. So we actually have to evaluate those now. Okay? So 1/3 log base 6 of 136. Minus 1, okay? So 136, we said that that would probably be a -2, right? Because 6 to the -2 power is 136. And then we kind of go through here. So -2 times 1/3, -2/3, minus 1, negative 1 and 2/3. You guys know that I don't like mixed numbers, so we're going to change that. It would be negative 3 5/3, so it's negative 5/3. Let's do the next one here. 1/3 log base 6 of 1/6 minus 1. So 6 to what power gets me 1/6? Negative 1. So that's negative 1/3 minus 1, which is negative 4/3. Okay, let's do the 1. So 1/3 log base 6 of 1 minus 1. So 6 to what power gets me a 1? That turns that log into a 0. 1/3 times 0 is a 0, so we get minus 1. Okay, and hopefully you can kind of see how this is working in your head. So put a 6 in there. Log base 6 of 6, that turns that into a 1. So it's 1/3 minus 1 is a negative, 1/3 minus 1 is negative 2/3. All right, 36 goes in there. Log base 6 of 36, well, that turns it into a 2, right? 6 to what power gets you 36? That's squared. So it's 2/3 minus 1. That is a negative 1/3. Okay, so you can see our change here is by about a third. If we go ahead and plot those points, 136, negative 5/3, so we're kind of down there. Next one, 1/6, negative 4/3, kind of there. And 1, negative 1, we're there. 6, negative 2/3, we're kind of right there. It's going to curve about like that, and it's going to approach 0, because remember we want to look inside with the x in order to figure out our asymptote, okay? If you set that equal to 0, you get x equals 0, and that'll tell you your asymptote. So domain will be x is greater than 0, range, all real numbers. So let's try this one down here. So this one's a fraction, and we have more than one thing going on in there. These ones, they get a little bit harder. So we want the x minus 1 to be those powers of 1/2. So what's 1/2 to the negative 2? 1/2 to the negative 2, that is a 4. Okay, so let's list these out here. X minus 1, so what's 1/2 to the negative first power? That's going to be a 2. 1/2 to the 0 power, that's a 1. Okay, so you can kind of see what we're getting at here. We're trying to find these x values that we want to plug in there. And let's say we want 1/2 to the first power, so that's just a 1/2. X minus 1 is going to be equal to 1/2. X minus 1 is going to be equal to 1/4. These are going to tell us the x values that we need, and then we actually have to plug them in. Okay, x, y. So the first x value is going to be a 5. Second x value is going to be a 3. Third x value is going to be a 2, and I'm just getting those from here. Add 1, add 1. Okay, 5, 3, 2, and then add 1, so we're at 3/2, and then we're at, so add 1, we're at 5/4. Okay, and since we said that these numbers are going to essentially give us those exponents, that's what the log is going to evaluate to. So for the 1/2, our log, or for this one, excuse me, our log is going to be a negative 2, right? I'll show you here. So if we did log base 1/2 of x minus, so it'd be 5 minus 1, which is 4. So 1/2 to what power gets me a 4? That's negative 2. So this log is going to give me a negative 2, which was that exponent. Okay, so it'd be negative 2 times 2, so it's negative 4. This one we said was going to give us the negative 1 exponent. So the log turns into a negative 1 times 2, negative 2. This one we said would be a 0 exponent, so log evaluates to a 0, gets me a 0. This one we said would be a 1 exponent, so log evaluates to a 1 times 2 is 2, and you can kind of see the pattern happen here. So then we need to go ahead and graph those. So 5, negative 4, we're down here. 3, negative 2, we're down here. 2, 0. 3/2, 2, so 1.5 up to 2. and then 5/4, 4. So 1 1/4 up to 4. All right, and so we're going to level off right at that x equals 1, and this is going to come down and start to kind of curve here. And again, you can see this is going to tell me where my asymptote is. And it's like everything we've done before, you think the opposite. So it's at x equals 1 is the asymptote, which would be this dashed line right here. We're never going to cross that. Okay? So I encourage you to look back at this video if you need help graphing them. I know that this is probably the hardest part of the lesson is graphing those, because you have to understand how they evaluate in order to graph them. But give it a shot. Here's your homework for the lesson. Try to work through those. Some of them are just switching from logs to exponents and exponents to logs, and then there's a few graphs in there. So you might want some graph paper for that. All right. Thanks for watching. Let me know if you have any questions.